Okay, so I wanted to talk about our exam, which is happening on Monday, week 8, Monday, and so that's scheduled to go from 9 a.m. to 10:50. So our class normally ends at 9:50, but I'm going to do one extra hour, so you'll have about just under 2 hours for the exam, an hour and 50 minutes from 9 a.m. to 10:50. It is going to be formatted a little bit kind of like the homework in that I'll post an RMD file and maybe a data file, and you'll download those things to your computer, and then you'll fill in your answers, you'll knit it to a PDF, and then you'll upload your PDF to Gradescope. So prior to Monday, you want to just test out a couple things, okay? One is make sure you can knit PDFs on your computer. You don't want to have that face the issue of like, my computer can't create a PDF the day of the exam, okay? So you want to make sure you do that. A general recommendation, just so you don't run into all kinds of problems, is that as you're working through the exam, save frequently, and then try knitting after every kind of like major code chunk or whatever, to kind of just make sure at this point it's working, okay? And then because what could happen is you make a mistake somewhere along the way, and if you have an error message, right, a lot of times your thing will not be able to knit. And so there's a couple things you can do. You can enter error equals true, which will allow the file to knit even though there is an error message. But obviously, it's better if we don't have that. And but you want to kind of just periodically make sure your file is knitting, so that 5 minutes before it's due, you're not in panic mode trying to get your thing to knit. Okay. If you do have class at say 10 a.m. and you can't do the full exam from 9 to 10:50. I will allow you to start the exam at 8 a.m. Just let me know, okay? Just let me know, and I'll be logged in at 8 a.m. and you can show up and start the exam at 8. But the exam materials will be it'll be posted on Bruin Learn. There'll be like a little password that you have to enter. So there's some kind of, I guess, security and control there. The way I'm proctoring the exam is done on Zoom. So you'll log in on Zoom with your cameras on, and I'm not recording. It's not. I don't know if any of your other classes make you use like a lockdown browser or anything like that for your things. It's none of that. Okay, it's just log into Zoom with your camera on, and that's just to kind of make sure you're taking the exam alone. It's fairly low level security, but hopefully it discourages any kind of like parties of taking the exam together or something like that. Okay. If your laptop's camera doesn't work, or you don't have a camera on your computer or something, you can log in with your phone or tablet or something. I assume all of you have some kind of device that is able to log into Zoom. And that should be that. Exams, open note, open book. You can look up help and documentation and things like that. It should be, I'm hoping, reasonable in difficulty and length. That's always a challenge, to kind of make sure it, when I write the exam, that it's a reasonable length and difficulty. I have posted a sample exam from that, basically the exam I used last year, so you can kind of take a look at something similar to expect for this year in terms of the format. Obviously the data file will be working is different. The questions that I ask of you will be different. But that's the kind of the format of the exam. Any questions about that? We feel okay? All right. Okay. All right. I wanted to talk more about the final project. I've had some groups come to office hours, and I'm grateful for the groups that come to office hours. Or even if your group just sends like one student, I feel it feels good to have like a little communication to kind of know what's happening in your group and to be able to help out. But I also know some groups are concerned in terms of just like what exactly are you looking for, and what kind of what do we want in the project? What constitutes an interesting relationship? Interesting findings and things like that. So I've posted a grading rubric on Brew and Learn. You can open that and we can kind of talk through that and walk through it. And then I've also posted a document that says final project suggestions. And so this is all in the module on Brew and Learn under final project information. So let's start by opening up the final project suggestions. And so I put 4 points here, and the points are: start with clean data. Number 2 is begin with your exploration with the basics, then dive deeper into more interesting relationships with subgroups, and 4 is test your findings. So, and all of these things, you should document and talk about in your report. In your final report, whatever code you've done, include it. Okay, so there you should never hide. For this final report that you'll be submitting to me, don't hide any of your code. Okay, so all of the code that you're using, include it in your report, and and I'll be able to kind of read through it and just check to make sure, things either I agree with it, or if I do have a question, I can see what the exact code chunks you ran. Perhaps in a maybe a business setting, you would hide some of this code, but for this class, I want you guys to include all your code. Okay, so the first thing is start with clean data, and this is going to be true not just for this class, but in any kind of data science, data analysis role. If your data is garbage, then your analysis is going to be garbage. So you want to make sure your data is clean, and I've talked a bit about this already, but yeah, just want to emphasize it. Yeah, question.
Should we include the cleaning up of our data?
Yes, include the cleaning up of your data and the code that you use to clean up your data should be included in your final report. So that's going to be things like looking for outliers, okay? And you have a little bit of that in the homework, this week's homework, where you're looking at the diamonds data set and you're looking at your variables x, y, and z. And when you look at variable x or y or z, there's outliers. And if you ask yourself, do these outliers make sense? They don't. And so we should remove them, right? Sometimes you have outliers and you ask yourself, does this make sense? And maybe it does, and so you can include it, okay? That was one thing that I think I had the example project of the Airbnb. I think that group did a good job of that. They went through their data, they found outliers in terms of like price, and then they just and they investigated those outliers. Okay, hopefully the manual investigation part of your outliers is you don't have like 1,000 outliers. You only have like maybe a dozen of them, so it doesn't take too long to investigate all of them. But yes, you should investigate your outliers. And if it doesn't make sense, for example, on the diamonds, if the y measurement is 0, okay, right? How can you have a diamond with a y measurement of 0? Okay, that's not going to work, right? How can you have a diamond where the y measurement is like 60, right? So if this is like in millimeters or something, 60 millimeters is like a couple inches long, all right? That's not a realistic diamond either. So So yeah, we should get rid of those, okay? So cleaning up your data includes things like searching for and getting rid of your outliers. Perhaps you don't want to delete them, and maybe you want to kind of do a separate analysis on outliers. That could be interesting in of itself, okay? Things for checking for duplicate entries, missing entries, missing values, what are you going to do there? And then sometimes you have variables that kind of just need to be cleaned up or converted. So if you have like a column of text and you need to transform them. So, one of the examples I did in class was, in this Netflix data, they had the different genres of the titles. This one was a crime movie, and this is a drama, and this one's a comedy, and things like that. That's all kind of text data that is difficult to work with directly. We created, kind of these dummy variables of, is it drama? Yes, true or false? Is it comedy? True or false? And that, I would say, that's all part of cleaning up your data, and include all of that. And if there are variables that need to be created, that's part of that. Make sure you're clearly defining all of your variables. One thing that I always kind of give groups a hard time about is if certain ideas are just poorly defined. If we say, hey, we want to look at what's related to player success, right? Here's a sports data set, and we want to know what variables are related to player success. Player success is such a vague term that you can't do a reasonable analysis. You need to define it much more narrowly, okay? And then you start to realize that this is difficult, right? So in basketball, if you define player success as just how many points are they getting, it's a flawed definition. We know it right off the bat, that looking only at points is a flawed definition, but at least that is clear and objective. And perhaps you need to have a more defined way, but it's very difficult. And that's why, when you ask somebody, who are your top 10 basketball players, everyone has a very different listing of who the top 10 are, right? Whatever sport you're talking about, who's your top 10 is going to be different. And that's because this idea of player success is not universally defined. It is a little bit more amorphous. And so as a group, you need to come to an agreement about how are you going to define this metric. And it might be as simple as okay, forget success in general, but just let's look at points only, or let's do points plus this other thing or something like that. And that's fine, but it needs to be clearly defined. Otherwise, vague terms just, it's not going to work well. Okay. So that's a start there. And again, define everything, document everything. If you say, if in your analysis you're going to say, we're going to use points as the way to define this, just talk a little bit about this, right? Have a small discussion in this area in terms of this is the question we're going after, and this is the decision we've made. And you can also discuss later on, the drawbacks of using, such a narrow definition of player success. Okay. And then as you do your exploratory data analysis, start with the basics. Okay. Always start at the basics. So start with these very obvious relationships. And that's fine, okay? There's nothing wrong with starting with the obvious relationships. When I say we want interesting conclusions, yes, we do want interesting conclusions. I will be disappointed if your ultimate conclusion is larger apartments cost more money, okay? That's not interesting enough for a good project. But you should start there, okay? So, hi. Thank you for coming.
No problem.
I'm going to keep lecturing if that's okay.
That's fine.
So, one of the groups is doing looking at apartment costs and things like that, and so yes, if the final conclusion is larger apartments cost more money, that's going to be a disappointing conclusion. But that looks a little. I want to make sure you guys are safe there. Okay. You know what? We'll pause. Okay. All right. I think we're recording and we're going good now. Okay. So yeah, start with the basics. So start with a graph that shows, okay, as the size of the apartment goes up, the cost of the apartment goes up. Okay. Start looking at these basic relationships. You have to start somewhere. Include those things, right? The more bedrooms the apartment has, the cost goes up. The more, I don't know, whatever this has, right? The cost goes up. That's fine, okay? Or if you have a categorical variable, you can say, this category has this average, and this category has this average, and this category has this average. Or, you create little box plots, and you say, all right, here's the box plot for this group, here's the box plot for this group, here's the box plot for this group. And what we see is that these different groups have different medians or whatever it might be. Start with a basic kind of relationship. Start there, right? And create appropriate visualizations. Create appropriate summary tables, and have just general discussions there, right? And then, so once you've kind of established the basics, then I would say the next thing you want to do then is to dive deeper into potentially interesting relationships. And I think one of the best ways to do this is by finding subgroups, interesting subgroups, and see if these the same relationships hold true for all of the subgroups, or perhaps for one or a couple of the subgroups, things are a little bit different, that you have like what we might say an interaction between the relationship and the subgroup. So for example, if we're talking about the cost of apartments, right? So your basic relationship is, as the apartment gets bigger, the cost of the apartment goes up. Okay, very reasonable, very very reasonable, but very simple. I think the next part is then to do a subgroup analysis and say, hey, you know what? If you look at these different neighborhoods, the relationship is a little bit different, right? In this one neighborhood, if the apartment goes up 100 square feet, then the cost per month goes up $100 a month, okay? Here's this other apartment, okay, but in this different neighborhood, if the apartment size goes up 100 square feet, now the cost jumps up $300 per month, right? And so you have the same kind of relationship where apartment cost goes up, okay, as size goes up, but the impact that size has on the cost is different in these different neighborhoods, right? So, perhaps, versus like, just imagine, an apartment in, say, New York City or even like Los Angeles, where space is at a premium, bumping up, 100 square feet or whatever, will increase the cost of your apartment. But, if you go out to some rural area, okay, or a much smaller city or something where, space isn't so expensive, then you can get a much bigger place for not that much more money. Okay, the general relationship of cost and size is still remains, but it's going to be different. Okay, other things I think that could be interesting would be perhaps a certain quantity or a certain trait has like an opposite effect, right? So you might, in your basic relationships, and when you're exploring basic relationships, you might say, overall, if this variable is true, the average for yes versus average for no is different, right? So you start off with kind of this basic thing, and you say, all right, average cost when the place has a pool is this. Average cost when the place doesn't have a pool is generally lower. And you can say, okay, that kind of trend where the average cost with the place is, costs more, is true for a lot of places. But then if we look at this one particular subgroup, the trend is reversed. And so this was a thing that a group found when they were looking at rental properties for kind of like Airbnbs and Verbos and things like that, is that generally having a pool, it was associated with a higher rental cost, except when you looked at zip codes that touched the beach. Okay, and those were generally indicative. Okay, and so what they found was that in these zip codes, having a pool actually was associated with a lower cost. And so the spec and so this part's also important. Okay, is like, unless you find research or have data to further back this up, you might have some reasoning, but it's important to just say, okay, this is my speculative reasoning as well. And so the speculative reasoning, which I would agree with, okay, is that the houses that touch the beach, the ones that are directly on the beach or very, very close to the beach, those places did not have pools. And it's only as you get further inland, when you're more than a mile from the beach or something, that's where pools start showing up on those properties. And so for those zip codes that were right along the beach, the cost, the rental cost would go down if the place actually had a pool. We didn't have exact kind of they didn't actually go out and collect all of the data to figure out all of those things, but that was kind of the general idea, and they indicated that, and I agreed with that. Other kind of interesting things. So I think one of them was an example of an A project that I posted was kind of this air flights data set and kind of the costs there. And they found, overall there was certain trends where, costs of flights were fairly similar for different airlines at different places, with the exception of at certain airports, some airlines cost much more. Their average cost was much higher than the other airlines. And so, again, looking at subgroups, for this particular airport, and looking at the cost of the, average cost of tickets, across different airlines and stuff, why was it, much higher? And they found that when the airline, so certain airports are used as hubs for certain airlines. So for example, if you're Delta Airlines, certain cities, I think Delta uses Salt Lake City as their hub. And if you're Southwest, you have this particular city airport is your hub, and American Airlines has something like that. And it turns out that airlines that use a particular city as their hub, they maybe have 70% of the flights out of that airline, and then and they end up charging more because it's kind of well, if you're going to fly out of this airport, you don't have any choice. You have to fly with us. And okay, so the speculation was a little bit maybe it's a captive market or something, but definitely they found this relationship where when the airport is a hub for a particular airline, the cost for that airline's flights are higher than their kind of competitors and stuff. And so that was interesting. And then they found, they investigated this further, and they found kind of news articles or, opinion pieces to kind of corroborate their findings, where people were kind of just complaining about, it's not just their imagination, why are flights from this airline out of this airport, much higher, and it just kind of reflects this, everybody in that city kind of has to fly with this airline, and there's only a few flights that from the other competitors, and so the hub airline gets to charge a little bit more and things like that. So So anyway, I would say those are the kinds of interesting relationships I'm hoping your group finds. And I think one of the best ways to find these relationships is by doing some subgroups. Obviously, some of these things, like you try something out and it's not going to pan out, or you're not going to find anything interesting. And I would say it's up to you and your group as to whether or not to include the ones that don't necessarily yield an interesting result, right? So you might do some kind of subgroup analysis and you find, you know what, the same trend exists for all of the subgroups, right? And I would say, you know, that's a tiny bit disappointing. Doesn't necessarily mean you don't include it, but it also doesn't necessarily mean you have to include it. So perhaps depending on how much effort and time you put into it, if you put a lot of effort into it and it just didn't pan out, you know, go ahead and include it. But if it was just kind of like, here's a quick idea, let's explore this, I'm not sure if we will find any kind of relationship, and indeed nothing interesting comes up, you know, probably you don't need to include it, okay? Subgroups don't have to be just on categorical variables. So you don't have to say, you know, for category A, this is the relationship we see. For category B, this is the relationship. You can create subgroups or different categories based on numeric variables using ranges. So you might have the numeric variable age, and you can create subgroups for that variable age using ranges. So you can have like the 18 to 24 group and the 25 to 34 group, 35 to 49, 50 to 64. And these are just kind of arbitrary cutoff points that I've made up. But I think a lot of times I see marketing using these kind of groups and categories. And so these are different groups that you could use as well. And so you can do that, and you can say, all right, is are the results consistent across all of the groups, or do we find something, you know, some kind of relationship here where, you know, if you say, what percentage of, you know, overall, the percentage of people who, you know, use a particular piece of technology, right? You know, percentage of people where email is their primary method of communication or something like that is probably going to be different for these different age groups, right? Different kind of subgroups. Overall, this is the trend that we see. For different subgroups, it ends up being different, okay? Or, you know, what's the relationship between this variable and that variable? And it could be different for these different subgroups. I think, so these are the kinds of ideas that I want you to explore. So that's my suggestion. So start with the basics. After you've, you know, started with the basics, then dive into something more interesting, and then go from there. And then finally, test your findings. So you might find that there appears to be a difference between group A and group B regarding their means, or group A and group B regarding their proportions, or group A and group B regarding, say, you know, the slopes of these things, okay? So now what we want to do is we want to perform statistical tests to say, could these differences be accounted for just by kind of randomness versus do they reflect an actual relationship or trend that exists? Okay, so if group A is, you know, 50% yes, 50% no, and group B is 52% yes and 48% no, right? Is that difference from 50% to 52% between group A and group B, is that something significant, or could that difference be attributed by random chance? And that's when you use a proportion test. Or, you know, if the average, the mean, whatever for group A is, you know, 15 points and the mean for group B is 22 points, is that difference significant, or can it be attributed to random chance, a difference between a mean of 15 versus a mean of 22 or something? Okay, there's even more statistical tests. The next thing I kind of want to introduce is regression. I think regression's kind of a big topic, and so I'll start by talking with a little bit of ideas and concepts today, and we'll get into it some more next week. But these are ideas that I wanted to give you suggestions for the final project. So, any, I guess, questions, and again, if your group is struggling or if you're not quite sure, come see me during office hours. I'm happy to help. I guess I'll go ahead and give you some view quiz answers. I haven't given you any yet, right? Okay, so we'll say our first two view quiz answers today are the letters A and C. A as in apple, C as in cat are your first two view quiz answers. A as in apple, C as in cat. Okay. Here is, I've posted this grading rubric file. All right. I need to update the date. But I've tried to kind of list off like what it is I'm looking for or hoping for in each of these things, in terms of like what should your research question and the motivation for all of these things should be. And again, if you're not quite sure, come talk to me. One thing I want to make sure you guys avoid is, sometimes there's a temptation when you have 4 people in the group, you just say, okay, you do this thing, you do this thing, you do this thing, and you do this thing. And you go in separate directions, and then you come back and you just kind of tape everything together. And a lot of times that kind of that strategy is doesn't pay off, because it's the overall kind of report just doesn't kind of have any kind of coherence. Person A, the first person, might have looked at some kind of particular relationship and then explored some kind of subgroup analysis there, and person B looks at like a completely different relationship and there's and a completely different subgroup analysis. Ideally we have there is some consistency, and of course you're going to have different kind of subgroup analyses, different kinds of explorations, but hopefully there is some kind of parallel reasoning or thinking here. Okay, so that's why meeting with your group and having kind of check-ins where everyone's on the same page is going to be important there. Okay, your writing needs to be kind of clear. Your explanations need to be good. Okay, and then so this just has kind of different sections. So I want to make sure your background information is also good. And then I've gone into kind of the data analysis portion. And so I have a section where you're going to be graded on data validity and data cleanliness. Now, if the data set you have is perfectly clean and valid and there's no issues, then this section might be pretty short. You don't have to do a whole lot. You should still include, like, we did do some cursory analysis to make sure we don't have crazy outliers. We don't have too many missing values or anything like that. So even if you are getting data from like an official data source where you're pretty confident everything's accurate, you still want to check for any kind of outlier issues and things like that, right? Okay, and then regarding the exploration of variables, start with looking at variables one at a time, and then look at your basic relationships, and then look at your in-depth relationships. Okay, all of these things should also include plots and data visualizations. Any kind of plot that you create needs to also have at least a couple lines of text accompanying it to kind of just make sure the viewer of the plot sees whatever it is you are trying to communicate. Hopefully your plots themselves are, I guess, compelling in that the viewer should be able to see the plot and understand what you're trying to communicate without having to read all of the lines of text. But you do need to include those lines of text just to kind of make sure the viewer or I am on the same page with you as the presenter, right? So if you present one thing and I'm receiving different information from what you want me to receive, that text kind of needs to be there to make sure we're on the same page there. Okay, and then finally include some parts where you do your statistical tests, your analyses, your data modeling, where if appropriate, we're checking to see if maybe we're making predictions, maybe we're just trying to see if the differences we're observing between subgroups is statistically significant or not. And then any kind of discussion is also important, and this is where you kind of include any speculation, and this part, the discussion conclusions can be interspersed throughout your report, or you can also keep it all at the end as well. Either form is fine, but just we should have some discussion there. Okay, and again, I've tried to list them off as good, basic, needs improvement. So it's kind of you have an understanding of what we're looking for, and then finally, when we have our final project meeting with your group, you'll give me a presentation about 5 to 7 minutes, and that should be good. Okay, so I hope this provides a little bit more clarity regarding your final project. You have just a little bit of time left. You got week 8 and week 9, I would say, really is going to be kind of your big weeks where you're going to be working on this. I don't have any more homework, no data camp exercises, no more homework from the textbook, but you should still be working hard on these projects, meeting regularly with your groups. And then I will have a sign up for during week 10 and week 11. So week 10 and finals week, I'll have sign-ups for when to meet with your group. I think I'll have an extra credit opportunity, and that is probably like week 10 Friday. We'll have maybe I'll have 8 groups or so, 8 or 9 groups, allow groups to do like a 5-minute presentation, just to kind of show this is our project and this is what we found. I think it's kind of fun to see what other groups did. And so this will be kind of an extra credit thing for all of open to all groups who want to kind of participate and show their findings. Okay. Well, that kind of, I guess, discussion of the final project kind of took up all of our class time. But that's okay. It's an important thing. I want to make sure you guys are on the right direction and things are going well. So again, come to office hours. I'm happy to help out, especially with any kind of coding challenges you might face, or visualization challenges, or if you just want some ideas in terms of what kind of subgroups should we be setting up, or how do I get these subgroups going, I can help. Okay, we've covered a lot of tools, but there are a lot of tools, and I would say I have given you a lot to work with, but again, you're still pretty new to this, right? And so don't feel bad about not being the most efficient, right? So your code's going to feel clunky, your analysis is going to be kind of slow and clunky, but hopefully you can kind of work through it. Hopefully the idea of thinking through and critically thinking about your data. These are kinds of the things that I want you to learn and pick up from this project here. All right, well, I'll go ahead and give you your last view quiz answer for today, which is the letter D. D as in dog. And we'll end here. Have a great weekend. We will see you Monday for the exam. So again, that's going to be, you'll take it at home or wherever you can find a quiet location. We'll see you online via Zoom. And good luck as you study and prepare for that. And have a great weekend.